Hello everyone, myself Piyush Tandil, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Power System Planning and Design, which comes in 4th year, 8th semester. Today we are going to start our chapter number 1, that is Transmission Line Design, and this is the module number 1.1. So starting with the introduction. So in introduction, we are going to see the introduction of transmission line design, then after classification of transmission line, which are different classification based on different aspects like voltage and distance, then after electrical design of transmission line. So starting with introduction, an electrical power is generated in power station. Okay, it is necessary to send this power to different remote areas so that with the help of distribution substation the power can be distributed. So ultimate goal is to distribute power to the consumer. The flow of power from power station to the main distribution station is called as a transmission line. So from the generating station to the distribution center, the transmission of the power is called as a transmission line. Okay, and the voltage generated is stepped up to the voltage of transmission. Then after, the power is transmitted through the transmission line conductors kept on the insulators fitted on the transmission tower. So how we are going to transmit our electrical power from generating station to the substation or to the distribution station? We are going to connect our transmission lines, and that is kept on, or we can say fitted on, insulator with the help of transmission towers. So transmission networks are high voltage transmission line which transfer bulk power from generating station to area of consumption. These are long lines. Okay, these are long lines. So the standard voltage used in India are 400 kV, 132 kV, 110 kV, or we can say 110 kV. There is a recent development in 476 kV transmission lines. Now we are going to see the figure 1. A single circuit transmission line may be seen with 3 line conductors pretending to be 3 phase, that are R, Y and B. And at the top of the tower there is a ground wire to protect the line of conductor from the lightning storm. Let's see the figure first. So here is the figure 1, that is a single circuit transmission line. Over here we have total number of 3 conductors, that is R, Y and B. These are the R, Y and B 3 phase transmission line, and on the top of the transmission tower we have our ground wire which is protect our 3 phase wire from the lightning strokes, and these are called as a cross arm. These are our conductors. These are the insulator strings. These are the insulator strings, and these both are the transmission tower. Okay, now moving forward, in figure B shows tower carrying 6 live conductors. Over here we are showing 6 live conductors. These 6 conductors constitute of 2 separate transmission circuit. Each consists of 3 phase wire, that are R, Y and B. At the top of the tower there are 2 ground wires to save the conductors of both the circuit from the lightning stroke. Okay, as we can see over here, there are total number of 3 conductor on the left hand side and 3 conductor on the right hand side of the tower. Okay, these are 2 different circuitry with the phase of RYB, or we can say R1, Y1, B1, and on the another side R2, Y2 and B2. And to protect these 2 transmission line, we are going to provide 2 ground wire on the top of the transmission tower. So for the circuit 1, we can say the phase are R1, Y1 and B1, which are shown over here, R1, Y1 and B1. And for the circuit 2, we have phase of R2, Y2 and B2. These are R2, Y2 and B2. Okay, so this is called as a double circuit transmission line. Now next is the classification of transmission line. So transmission line are generally classified as short transmission line, medium transmission line and long transmission line. Okay, So what's come in short transmission line? So we are going to see every each and every types in detail. So short transmission line, the transmission line having length less than 80 kilometer. Okay, over here remember the term less than 80 kilometer. At that time the transmission line is called as a short transmission line. So the transmission line having less than 80 kilometers and operating voltage less than 20 kV. Okay, operating voltage less than 20 kV are generally known as a short transmission line. So due to small distance and low voltage capacity, due to small distance and low voltage capacitance effect is negligible. Okay, we are going to neglect the effect of capacitance in short transmission line. Hence, performance of these lines depend upon resistance and inductance only. So the parameters are going to be defined as R and L only. These are the lumped parameters. Okay, and we are going to neglect the capacitance of the short transmission line. Although resistance and inductors are distributed along the line, but in short line, these constants are assumed to be lumped at a phase. Okay, these constants are considered as a lumped at a phase. So remember the term, we are going to neglect the capacitance effect in short transmission line and only going to consider R and L, that is resistance and inductance. Okay. Now in medium transmission line, the transmission line having length between 80 kilometers to 240 kilometers, the line voltage between 20 kV and 100 kV. These are the parameters for the medium transmission line. So distance between 80 kilometer to 240 kilometer and line voltage between 20 kV and 100 kV are considered as a medium transmission line. Okay, due to the appreciable length and line voltage, the charging current is appreciable and therefore capacitance effect need to be considered. So in medium transmission line, we are going to consider the capacity effect while calculating the parameters. Okay. Now, although capacitance is distributed uniformly over the entire length of the line, yet it is assumed to be concentrated at a source or concentrated at some or more points. Okay, it is distributed on the transmission line, but we can concentrate on some points only. So at that time we are only going to consider at a point capacitance. Okay, now moving forward in the long transmission line, the transmission line length above 240 kilometers, the line voltage above 100 kV are generally considered as a long transmission line. So what is the distance in long transmission line? It is 240 kilometers and the voltage that is above 100 kV. Whenever the voltage exceeds the 100 kV, we can consider it as a long transmission line. Okay. Now we are going to see the electrical design of transmission line. Okay, so selection of transmission voltage, that is the primary term we are going to do while designing the electrical designing of the transmission line. So we need to first identify the voltage level. Okay, so how we are going to find the voltage level? With the help of power. So the power P to be transmitted over a transmission line is, this is the equation of power, that is P is equal to root 3 V into I cos phi. This is the power equation in three phase. Okay, we all know about this equation. Now the current I depends upon the product of current density. So whatever the value of current depending on the density of the current and cross sectional area, and second thing, that is the cross sectional area of the conductors. So both are fixed. So current density is also fixed because the material of the conductor is fixed and cross sectional area of the conductor is also fixed. So only variable is transmission voltage. So what is the variable term in this equation? Only the voltage, that is the variable term in this equation, because I and cos phi is going to be fixed and the value of I depend on the current density and cross sectional area of the conductor. So from this statement we can conclude that the higher the value, the higher the value of voltage, the higher the power that can be transmitted. So if we are going to increase the value of voltage, the power transmission capacity is also going to be increased, or we can say if we are going to decrease the voltage level, at the same time the power transfer capacity is also going to be decreased. Okay, so as the voltage is increased, the cost of conductor is going to be down, but the cost of insulator and the tower is increased. Okay, remember this term, as the voltage is increased, the cost of the conductor comes down, but the cost of insulator and tower is going to be increased. This is because superior type of insulator in large number are required, and also the height of tower is also going to be increased, because we don't need our current to flow from insulator to the tower to throughout the ground. Okay, so to compensate this effect, we need to increase the string of the insulator, and if we are going to increase the string of the insulator, the cost of insulator is going to be increased. And if we are going to increase the voltage level, at the same time we are also need to increase the ground clearance, so height of transmission tower is also going to be increased. So tower transmission, for the higher voltage level, the cost of insulator is also going to be increased, and the transmission tower is also going to be increased. The rating of cost of substation equipment like transformer, switch gear, protecting device, etc., will also increase. So whenever we are increasing the voltage level, all these parameters value is also going to be increased. Now, therefore, while the cost of conductor decrease at higher voltage transmission, the other cost is going to be increased. Other cost, which other cost? This is like the insulator, the tower, then after transformer, switch gear, and protection equipments. Okay, so as compare, comparisons or compromise is made between these two. So whenever we are going to increase the voltage level of the transmission line, at that time the cost of the conductor is going to be increased, but that need to be compensated with the help of the whatever the cost we are going to use in increasing the tower cost of tower, and increasing the cost of insulator and other substation devices. Okay, so this value need to be compromised. Okay, when the overall cost and voltage is plotted, the V curve shape is obtained. The voltage corresponding to minimum overall cost selected. Okay, whatever the minimum voltage level, we can select that. For that, V curve minimum cost is going to be considered. Okay, so the standard voltage level used in India are here are some standard voltage level that important for you. So what is the short transmission line? That is 11 kV to 22 kV and 33 kV. These are the voltage level for short transmission line. For medium transmission line, we have 66 kV to 110 kV. And for the long transmission line, we have voltage level of 132 kV, 166 kV, 230 kV and 400 kV. These are the voltage level of short, medium and long transmission line. Now we are going to see the table, that is this table indicate finding the loading of transmission line. With respect to loading, we can select the level of our voltage. Okay, so following table is very useful for finding transmission line loading. So here are the line to line voltage, and here are the line loading in kilowatt into kilometers. Okay, whenever we need to fade some power at a remote location, we have one data only, that is the what is the amount of power that is required. So depending upon the line loading, we can select our line voltage. Okay, depending upon line loading, we can select our line to line voltage. Okay, so if we can say our line loading is 200 into 10 raised to 3 kilowatt into kilometer, at that time we can easily select 33 as our line to line voltage in kV. Okay, so this is important table whenever we are going to calculate, or we can say whenever we are going to calculate some examples, at that time we need these tables. So you can also screenshot this table or write down in your notebooks. Okay, next table, for depending upon the length of the transmission line, the line voltage is selected. Okay, whenever we are going to also a distance between two remote far areas, at that time this is the minimum distance and this is the maximum distance, and for that we can select our line to line kV. Okay, for the minimum distance and maximum distance, we can select our line to line voltage rating. So if our minimum distance is between 15 to 30 kilometers, okay, this is the in kilometers. So the value distance is 15 to 30, at that time we can select 11. If our distance is 50 to 160, at that time we can select 132, and so on and so forth. Okay, so this table is also important whenever we are going to calculate, or we can say design of electrical transmission line. So note down these all the values in your note also, or you can also take a screenshot and print it out. Okay, thank you. If you have any kind of query regarding this, you can ask me in comment section. Thank you.